you first log in, you'll see this kind of home screen, which shows a lot of documents you may have worked on recently, and is kind of similar to Google Drive. What you see here might be things that are shared with you. It might be the things that are private to your account. So for example, these are all things that I've had open recently. Some other key points of this screen are in the bottom left here. It says the type of subscription that you have. Hopefully this says education, otherwise you won't be able to save private documents in your account if you just want to make test drawings or quick sketches. And also on the left here, hopefully we've added you to what the FRC or FTC Onshape teams. So you can see that I have 5026 here, and if I click in, I can see all the content that's shared by across the entire 5026 team. Previously on GrabCAD, we made one folder per year, so really one folder per major robot, so I expect that we'll continue to do that. These folders are owned by the burlingamerobotics@gmail.com account, which the lead should have access to if we need to add people to teams, if we need to make new folders, etc. So to create a new document from here, you can use the Create button and create a new Onshape document. Anything that you create documents and folders actually goes into your own private account, and then you have to go back later and either move it into one of the shared folders or share it with people individually. So I'll just create a new document really fast, and since eventually this series of videos will lead to making a frame, let's call it let's just call it a test drive base. Great. So now I get dropped immediately into the editor for Onshape. The first tab they've created two tabs for us. One of them is the Part Studio, and the other is the Assembly. The Part Studio could be used for making one part. It could be making multiple, but anything where you need to define geometry or dimensions will happen in the Part Studio or multiple Part Studios. And then you can bring those parts over into one or more assemblies to actually tell the program how to put them together. So I have an extra window open on the left here called Tabs. I noticed that in some larger assemblies, like if you look at the Citrus Circuits robot, to make some things easier, they put a lot of their robot into one Onshape file. That means they have like hundreds of tabs across the bottom. So to make this a lot simpler to view, you can open that extra window by clicking the Toggle Tab Manager button on the bottom. And you can see that it helpfully adds extra text telling you to use Alt-T as the shortcut. So I'm going to leave this open. Some of the stuff that you can do here that you can't just do on the bottom too is, for example, you can add folders, and then you could even move like parts into the folders, for instance. So I'm just going to undo that here. But essentially every subsystem in the Citrus Circuits robot has a folder. So there's like a drive base, there's an elevator, and then they have all the subparts listed under there. Okay, let's talk about what we want to make. So I'm going to jump over to our 2019 robot CAD. So you can see that here in Onshape, and we're going to make this is like a really nice 3D assembly, but it starts at the most basic level by making these like 2.5D shapes. So you can see that we make a lot of things out of these flat plates, like this one here that holds up the ramp pulleys. And I call it 2.5D because there's really only two dimensions of geometry that matters, And then the third dimension is just that the material stock is some height. So specifically, let's make this gusset here comes from Vex. Let's make a specific version that fits here in this corner. So in this case, the bracket has our standard hole pattern. So there's a 1/2 inch between holes. These are for 3/16 rivets. You can see that there's, we try to have 4 holes here in each direction. But the fun part is that our drive tubes are actually, instead of being 1 inch wide like the front, the drive tubes are 1.5 inches. So they have twice as many holes. So let's make a bracket that's specific to this like double width hole pattern. I'm going to jump back to our new document, and here we're presented with blank 3D space, and there are some blue things here, but these are all basically just empty reference planes. So to get started, we need to define a sketch, and you have to put a sketch onto a plane that already exists. So once you create more geometry, you could use an actual like a face of a part. But since everything's blank right now, let's just pick the top plane. So this isn't a real part. It's just like this dot in the middle is like 0, 0, 0 in coordinate space, and this is just the top reference. So we select the plane. You can either select it over here, or you can select it in the feature tree on the left, and then hit sketch or Shift S. Great. So now we have this sketch here. It's a little bit weird to look at it like this in 3D space. So you could rotate yourself up to the top. So I can do free movement by clicking the right mouse button and then dragging around. This is a little bit different than the SolidWorks command. So if you're used to SolidWorks, there's apparently like a SolidWorks scroll mode that you can use, but I'm not using that here. So the other way to quickly jump to one view is by clicking on the cube over here. So you can also, oops, that actually doesn't do what I thought. So if you just click on the top, or for example, if you clicked on like one of these corners, it would change your view. But let's just go back to the top. There we go. So to start off with, we know that we want to make a bunch of holes. So let's start with the center point circle. And you can see if you hit the arrow, you can get different kinds, but the default one is this center point circle. So the way this works is, sorry, I deselected it. So it's active. This tool is active when it's selected blue over here. So if you click it again, or if you hit escape, it will deactivate. But now that it is blue, I can click anywhere to define the center point of this circle, and then I can drag to kind of make another point. Exactly what the dimension is here doesn't actually matter. And the reason for that is because CAD tools like Onshape and SolidWorks are parametric. So in order to actually, right now there's actually nothing that's defined about this. So you can tell that because it's outlined in blue. So both the dot in the center, I hit escape so that I would deselect the tool. Both the dot in the center and the edges on the outside are blue. So you can see that if I drag this around, it'll just freely go. And if I drag this, it will change the size. So in order to tell the computer exactly where we want it to go, we have to add dimensions. And these can be changed later. That's is one of the parameters that we're putting in the system. So we could either hit this up here or hit D on the keyboard, as you could see the shortcut there. And now that it's highlighted, let's first put it somewhere in space. So if we select that, I selected the dot in the middle, and then I'm going to click on the origin point here. It's often useful to reference off the origin point when you get started. And let's put this a ½ inch in. So we're going to put 0.5 inches. And this, we usually do most of our parts in inches. So if the CAD system will actually automatically change it. If as long as you put IN or millimeters, it will actually convert it to whatever your document units are. I think the default is in inches, but I may have changed the document units elsewhere. So let's put that 0.5 inches in here. And I'm going to put it again. So you can see that it's changing between different kind of dimensions. So you can either have aligned, where it's like parallel to the imaginary line between the points, or it can be fixed to your like X and Y 90 degrees. So in this case, I want the fixed version like this. So let's put another 0.5 inches in. Great. And then we need to give this a diameter. But to figure out exactly what diameter, we're actually going to reference the rivet information. So let's put this in, and I'm just going to accept this default value. So let's go look at the data sheet for this rivet. So I'm on McMaster-Carr, which is where we get a lot of our parts, and you can see that it says for hole size 0.192 inches to 0.196 inches. So let's put in 0.192 inches on the small side. Okay, hopping back over here. So to edit a dimension that is already in the drawing, we can just double click on this and put in what we found from McMaster-Carr, 1.192 inches. Great. So now we've got to this point where we have a single hole in the screen. This is great, but you know, you can see if you zoom out over our robot that we have lots of holes. They're in a fixed pattern. Part of using the computer system to do this is that we don't want to be drawing all the holes individually. So let's use the linear pattern tool. And it kind of looks like squares and it goes in both directions. And that's exactly what this will help us do. So if we select linear pattern, and then we hit the circle. Now there's a bunch of arrows that appear on the screen in either directions. So the 3x, 1x is telling you how many of these you want in each direction. In this case, let's put the 1 by 1 frame is going to go up, and the 1.5 is going this way. So I think what that means is that I need, so I have 4, 5, 6 holes going this way. And then I'm going to need 1, 2, 3, plus 4, 7 holes going the other way. So I'm going to put 7 times there, and you can see that it filled out a bunch. Now these are obviously spaced too far apart, so we'll get back to that in a second. And then here I'm going to put 6 holes this way. And okay, so now we have a grid. And you can see that there's these helpful dimensions for how much space there is between the holes. So we typically use a ½ inch between holes. So let's put that in here, 0.5 inches. Great. And so now we have a bunch of holes, and there's a little icon next to my mouse that says click left button to finish. So I'm going to click left button here. And now we've got a bunch of holes, and they just went from blue to black really fast as it calculated that you have that all of these are constrained, right? So if I try to go in, so you can see that the little icon that pops up is what it's constrained by. We'll talk about exactly what constraints do in a minute, but the fact that these are black is good, and you can see that I can't drag them around. Okay, so let's define the outline metal of our bracket. So we know that, and I probably should have mentioned, we're going to do a right angle bracket instead of a T for this application. So let's draw So I'm using the rectangle tool now. So that's the one over here, corner rectangle. This is useful because you can define the two corner points and it will automatically put in, unlike drawing lines, if you use rectangles, it will automatically put in like your 90-degree corners. So I'm going to start over here at the origin point, and we're basically going to surround the holes. And then I'm going to put another one that goes this way because I actually put this in the backwards direction. So this is going to cover these holes, and this is going to cover in this direction like this. Okay, so you can see that these lines are still blue. But before we get there, I want to show one more trick. So if we wanted to make this an L shape instead of two rectangles next to each other, you can see that if I highlight this, there's one line here, and then I'm going to hit the backspace key to get rid of it. But then there's still a line that's left over here. So one of the techniques to get rid of this is, and it's not necessarily a problem that it's there, but we can use the trim tool. There's a bunch of helpful tools that help you manipulate lines automatically, things like offset, drawing slots, mirrors, in this, extend, but let's use the trim tool here. And I'm going to basically slice this section of the line out. And what that's left us with is I can now delete this section. So the trim will truncate a line where it's crossed by other lines. And so what that helpfully left us with is this, this L-shaped area. So now we're going to define how big that L-shaped area is. In this case, I know it's like 1 inch, 2 inches, 3.5, and then I'm actually not going to put another 0.5 to go 4 over here, so let's just put in 3 3/4 inches. Great. And then, so in this case, I selected a dimension that was, I clicked on this line and then I pulled it down, which will dimension the length of this line. But it's possible to also, for instance, because this edge is made of 2 segments, it's actually possible to define between either this point and this point, or for example, I could define between this line and this parallel line by clicking the 2 in series. Okay, so now I'm going to put that this is 3 1/4 inches tall. And I'm just going to click and drag some of these dimensions into a more orderly state. Okay, and you can see that some of the lines are turning black, but not all of them yet. So, for example, these are still blue because they could move around like this. So let's fix that up. So counterintuitively, we're actually going to click the black line here to fix these 2 in place. So we know that this is supposed to be 1.5 inches wide, and you don't have to put an inch here if it's your default units. So I put in 1.5 and it just snaps. And then I'm going to also give this one a 1 inch dimension. Great. So they're actually still, oh, okay. So I lost one of my right angle constraints when I was doing that trimming. So let's talk about some other constraints for a minute. So I'm actually going to delete this line, and some other things that you can do, for instance, are, so there's a whole selection over here. I'm actually going, so there's a coincident constraint, which basically makes 2 points share the same location. So, and that's kind of what I want. Like, I shouldn't be able to drag this around, basically. So I'm going to select this coincident constraint. I must have made a mistake. It usually auto snaps to this point, but it's a good point for the tutorial. So I want to select this and then select this origin point, and now they are stuck together forever. So these won't move around. Another useful constraint, for instance, is this is fine, but it's kind of like moving around like this. We meant for it to be a vertical line. So I can just select the vertical constraint, hit this guy here, and now it's fixed to be vertical. So we still see a problem here. I'm not really sure where our perpendicular went, but let's just hit perpendicular between this, and now they're stuck in place. Okay. You may notice that we have actually extra circles from what we intended, but we can fix this up pretty easily by, so the solid geometry is what the system will see how it's calculating the area here by highlighting like the most inside area. But if we wanted to ignore all these circles and we still wanted to have them drawn for some reason, we can convert them into construction geometry. So we're going to select, so I click and drag to select the field of things over here that I don't want. And then we're going to right click on one of the edges and hit construction. And now they all go into like little dashed lines. And if you zoom in, you get more dashes. But the key part here is that now our outline doesn't go through these dashed lines anymore. It basically ignores them. So it lets you, there's a lot of helpful ways to use construction geometry when you're kind of making hypothetical dimensions. But now we have our L. It has, let's say there was a tube here. It has your 4 holes going this direction. Let's say that we had a tube here. It has your 4 holes going this direction. The only thing here is that if we go into orbit mode, it's all flat. So right now we have a 2D drawing. That's pretty much what the sketch system is good for, but we need to give it some 3D-ness. So we're going to hit this check mark here for sketch. Okay. So to make this into a 3D object, we can highlight the sketch, usually over on the feature tree, and then we use the extrude tool. So we just hit that, and now you can see that it gives it a thickness. And because we drew all those circles down ahead of time, it actually includes, or it doesn't put anything in the circles either. This is obviously way too thick for a plate, so we're going to pick the blind type. That's the default, but then we need to set the depth to something reasonable. So a common plate thickness like the Versa plates will come in 3/32 inch, and you can actually type a fraction if you don't remember what that is in decimal, because the fractional system is kind of ridiculous. Then you can just type in 3/32 inches, and it will helpfully convert it automatically to a regular dimension, and then we just hit green check mark, and now we have a 3D object. Great. So in order for this to be really useful to us later, this is we could basically use this now, but if we wanted to bring it into an assembly somewhere else, it currently has the name Part 1. So you can see that when you made this extrude, we got this new parts list at the bottom. If we want to give it a name that would make sense if you see it in another assembly of the robot, we can just right click on Part 1, give it rename, and let's call it gusset 90, or we'll just describe what it is. And in this case, it's specifically a 1 by 1 on one side and 1.5 on the other. So we're going to give it this name. Okay. As well, when you're, so if we think towards actually cutting this out on the machine, there's, the outside edges are okay, but these are kind of sharp. The inside edge, you actually can't make a perfect right angle at the inside because the milling bit has a certain diameter. So we need to go back and add some curves to this. So the great part about this is that there's actually some history built in, so we can edit the things that are we already drew, and they will regenerate the drawing. So to edit the sketch, for instance, we can double click on it, and you get this sketch 1 box coming back up. So there's a couple ways to add curvature. One way is to use a fillet, a sketch fillet. So a fillet's like a round edge. So we can do that, and then you just select this edge, and then you select that edge, and it gets some diameter. So let's just you can see that there's a mouse with a left button over here, so we'll just select OK. I'm going to do one more of the, oh, and then I just clicked away the dimension. So if you actually do a bunch in a row, like if I did this edge as well, you can see that it just comes up, and then I'm going to do this edge, and you can see that it gets a curve, and then I click OK. And because this is an extra feature of Onshape, because I selected the same radius for all of them, it actually made them all to be equal radius, and it only drew the dimension once. You can see it up here. What that means is that if I want to change this, let's say I think that a 1/4 inch, 0.25 inches is too much curvature, I could change this to an 1/8 inch. And now you can see that they all change together. So that's the nice part about having constraint-based drawings. But actually, I think a 1/4 inch is, well, this is radius. Let's put it between the two, and we'll go to 3/32 of an inch. I'm sorry, that's not the right number. We need more than an 1/8, so 3/8 inch radius. Okay, 3/16 inch radius, which would be between 1/8 and 1/4. Great, that looks more reasonable. So now if we hit the green check mark here, you can see their rounds are just automatically added to the 3D shape. You can also add the fillets in 3D space. So now that you're outside of the sketch, this toolbar totally changes to 3D items. You can see that on the same toolbar as extrude, you get things like fillet, chamfer, which is like a slice on the corner. You get all of your different option, like popular attributes like shell and hole that we'll talk about later. So let's go to this fillet, and now it's asking the 3D command window is a little bit more interactive. So when there's a blue box like this, it's asking you to give it an object or geometry, basically. So it says entities to fillet. What it's looking for in this case is edges. So like here, we're going to select to this edge, and this edge, and this edge, and you can see that they're being filled into the blue box, which is great. And then we go over here to radius, and we can put in that 3/16 inch radius again, and you can see that it's kind of drawing it in shading on the actual part. So let's hit check, and that becomes a permanent part of the part. So honestly, to make the geometry simpler in Sketch, we usually add these fillets in later. So let's go back and actually add a whole new. This is good in a lot of cases, but there are some places. We had some gussets that another team used at Chesney that actually had like a piece of metal going across this rib, and that can make it so that there's not as much bending load on this corner. So let's go back and actually add some kind of complex geometry to the sketch. So I'm going to start with a line over here. So we're gonna kind of fill in this corner, but we actually want to define a rib over here. You can actually see that it's as you move along, it orange highlights this other line over here, and you can see that there's a small box with two parallel lines. That's an auto insert of a constraint. But just to go over the constraints one more time, so let's actually make it somewhere else like this, and you can see that the line is blue. You can kind of drag it around like this, but we really want it to be parallel to this line over here. So we're going to manually insert using this constraint section of the toolbar, a parallel constraint. So we select to this line and then this line, and now they snap to being parallel. but it's still blue because it could be moved around in space like this. So to fix that part, we're going to add a dimension from here to here, and let's give that a 3/16 inch as well. Actually, 3/16 is looks a little small. Maybe this one I might actually be better at 3/8 inch. Yeah, that looks pretty good. Okay. So we're going to click OK on the sketch. And in this case, the extrude has actually selected that automatically to be part of the face. It is possible to edit it if it was like, let's say you actually wanted to include this middle section, you could actually click here and include it. But since we didn't actually want that, I'm going to then go over to this box, and the new line that was added, we're going to click X right here to deselect it again. You could also click on it and then click on the space you wanted to remove. That would get rid of it. Okay. What we are missing though is, like we talked about in this corner on the inside, these really sharp edges are not able to be machined. So some of the fillets that we had already selected were automatically changed, but we need to add a few more. So to do that, we just go back to our feature, double click it in the feature tree, and select this blue box. It was actually already selected because it's the only one. But then we can just go and add additional places that we wanted to fillet. So we can add like this line and this line, and to select this area again, to orbit, I'm doing a right click and then dragging my left finger on the touchpad or just moving the mouse. Okay, and you can see that it's kind of shaded in as filled into those areas. And we just hit check mark to accept. And now our part has been modified in 3D.